Okay, in this video, guys, I'm going to be helping you out with problem 5 in your homework. It's an AP free response from a few years ago. So in this problem, we have a consumer, Sasha, who is maximizing her utility and is spending all her income on peanuts and bananas. So when you read through this, you can figure out the marginal change in utils for both the next or the last unit of peanuts consumed and the last unit of bananas consumed. It's 8 and 4. So that's your a ratio of MU1 over MU2, and you know the price of peanuts is $1. So you simply apply the rule for maximizing utility that we learned back in chapter 8. So we have 8 over 4 for peanuts. The marginal utility was 8, and for bananas it was 4, and the price of peanuts is 1. So you simply solve for the variable, the price of bananas that you don't know, pretty easy, and you come up with the price of bananas. Now, the next part of this is asking us what would happen if the price of peanuts increases and the price of bananas remains unchanged. So we can just simply say, well, she's going to purchase less. Sasha, I should say, is going to purchase less peanuts. But let's look at why that is, because I think it's important to really understand how to apply the marginal thinking to this. Okay, so to make this make more sense, I just went ahead and assumed, and you could use any income you want, but I just made it simple and said, okay, well, let's assume that, excuse me, Sasha's income is $40. So she has $40 to spend on either bananas or peanuts or some combination of the two. So if bananas are 50 cents per unit, the maximum a unit she can buy of bananas is 80. And if peanuts are $1 a unit, the maximum units of peanuts that Sasha can buy is 40. So that's where we want to draw our budget line right here, this black line. Now, this U1 is one of Sasha's indifference curves, and the way we want to think about this is that her utility is maximized at any point on this purple curve. Her utility is maximized anywhere along here, but there's only one point that she can actually afford, and that's where this is tangent to her budget line, which is about right in here. And that's also where the slopes of the two curves are equal. So if we think about that, it makes perfect sense, because if we look at the slope of the budget line here, it's the change in the y-axis over the change in the x-axis, which is 80 over 40, which is 2. Well, it's actually a negative 2, but we're just using absolute values. So the slope of her budget line is 2. So we go back up here, we found a point where she's maximizing her utility with a slope of 2. 8 over 4 is 2, which would be right in here. And then if we think about that a little bit more, what that means is since she's getting twice as much utility for the next unit of peanuts at that point than she is for bananas. And if we think about this, where we are right here, she's willing to give up more bananas since it's a slope here, it's a slope of 2. So as you move in that direction, she's giving up more bananas for less for peanuts, right? So peanuts at this point right here are worth more to her than bananas, because as she moves in this area of the curve right here, she's actually losing more in bananas than she's gaining in peanuts, and it's actually twice. And that's because her marginal utility for the next unit of peanuts is twice what it is for the next unit of bananas, but only at this point right here. Okay. Now, let's say that the price, so now let's just assume that the price of peanuts went up to $2. That's actually what the question was, is what happens when the price of peanuts goes up and the price of bananas remains unchanged. Okay, so if the price of peanuts went up, doubled and went up to $2, that would mean that we would have a new budget constraint, this blue line, because she could only buy half as many peanuts because their price doubled. So if they're $2 and she only has $40 to spend total, then she can the maximum units of peanuts she can buy is 20. Okay, so now we've changed our budget constraint from the black to the blue, and we're going to have to go to a lower indifference curve here and find that point where it's a tangent, and that's going to be at a slope of 4, right? 4. So it's going to be even steeper, and it's somewhere in here. And so if we look, she's moving from here, somewhere in here, to somewhere up here. So she's obviously buying fewer peanuts. So she's moving from there to there, which is less peanuts. But we can see how that works using a marginal analysis and seeing how her budget constraint is going to shift from here over to here. And since the price of bananas remains unchanged, that means that this point right here is the same. Okay, so she's here. All right. Okay, let's see. Now we want to, part B, we want to assume that the cross price elasticity of demand between peanuts and bananas is positive. Okay, a widespread disease has destroyed the banana crop. Okay, so now we know two things. We should know, because the cross price elasticity of demand is positive, we should know that that bananas and peanuts are substitutes of each other. And if a widespread disease has destroyed the banana crop, that means the price of bananas are going to go up because the supply curve is going to shift to the left. So the price of bananas are going up. And so what will happen to the equilibrium price and quantity of peanuts in the short run? Well, if we look at our formula right down here for the cross price elasticity, and if they're going to be positive, in other words, both the numerator and the denominator are going to be moving in the same direction. So if there's a percentage change in price on one, if it's going to go up, so if bananas are going to go up, then the quantity demanded of peanuts is also going to go up, because when they're substitutes, the percentage change in a quantity of one moves in the same direction as the percentage change in price in the other. So you can sort of look at how this formula works right here. And once again, if you look at this, let me grab my little ball here so I can show you. If you look at this point right here, and let me do this real quick. Sorry. I want to move it to the front. There we go. So this part right here, they're actually taking the average. Okay, and we're computing the percentage change in quantity over the percentage change in price, and we should say that because let me jump back to the question here. So it's saying how will Sasha's where were we? Yeah, what will happen to the equilibrium price and quantity of peanuts in the short run? Okay, so they're going to go up the um, let's go back over here. So if the price of bananas goes up, then the quantity demanded of peanuts is going to go up, and if the quantity demanded of peanuts goes up, then the price is also going to go up. So it's going to be the price and the quantity demanded both of peanuts are going to go up as a result of the banana crop being destroyed. Okay. Sorry for that pause. I just wanted to make sure I didn't say something backwards or the opposite of what it actually is. Okay. So it's just going back here. It's just really important for you guys to be familiar with how this cross price elasticity of formula relates to whether the goods are substitutes, complements, or completely unrelated. Okay, let's go on to the last part of this. So now we want to assume that the price of bananas increases. Will the substitution effect increase, decrease, or have no effect on the quantities of bananas demanded, and what will happen to society's real income? So we need to understand then how the substitution effect works as well as how the income effects works. So I hope I have time to go over this. I got about 2 minutes, so let's see. So what I'm going to do here is I'm going to take some of this stuff out so I can explain to you how this works. Let me just move this out of the way. So we're actually starting off here, okay? Now what's happened in the problem is that the price of bananas goes up, okay? So if the price of bananas goes up, that's going to mean that we can buy, wrong one, let me go this way, that we can buy fewer bananas. So our curve is going to shift. We'll stay where we are in terms of the maximum amount of peanuts, but we're going to be able to buy fewer bananas because the price has gone up. So we're somewhere in here. Now, in order to compute the substitution effect, we want to draw a budget constraint, sort of a phantom constraint, parallel to the new budget constraint here based on the higher price of bananas, but on the original indifference curve. So that's going to put us somewhere about right there. And we want it to be tangent to the original indifference. And that's going to move us to a point about right here. Okay, so going from the green to the purple is due to the substitution effect. Now, so that's going to mean that we're going to purchase, going from here to here, it means we're going to purchase fewer peanuts. And also fewer bananas, right? Because it's asking us what will happen to the quantity of bananas. So that's going to make us purchase fewer bananas. That's going to be as a result of the substitution effect. Now, the income effect is going to be based on the new budget constraint here, the solid blue line, and we're going to be at a lower indifference curve here. So we're going to put that somewhere in there, I guess. And we're going to say that we're going to keep our peanuts the same. Okay, so we're going to come down from here to here and end up about right there. So if we keep our peanut purchase the same as we were originally, it means we can obviously are going to buy fewer bananas with this new price. So it means our buying power is lower. So this new budget constraint and the new indifference curve here shows us the income effect, and it shows that her buying power in a real income goes down.